Exercise 209, the intersection of lines. A pair of equations such as y equals a half x plus 1, like this line graphed here. Notice it's got a y-intercept of 1 and a gradient of a half. So rise 1, run 2. And the line y equals 2x minus 2. 2x minus 2 is a steeper graph. It's got a y-intercept at negative 2. It would have a gradient of 2, so 2 over 1. If you sketch any two lines with a different gradient, they will cross each other at some point. They will have a point of intersection. So they can be solved together to find the values of x and y that solve both equations. Now, the value of x and y that solves both equations is the solution to the simultaneous equation. We call it simultaneous equations because we solve them at the same time. Now, if simultaneous equations are graphed on a number plane like this, the solution of their point of intersection is where they intersect on the graph. For example, the point of intersection here is x is 2, y is 2. So the point 2, 2 on the graph, point of intersection, means the solution to the simultaneous equations is x is 2, y is 2 in that particular example. Now, in question 1, so for each graph here, we can see the coordinates of the point of intersection, but I just thought for a bit of revision, let's work out the equation of each line. So I'm going to call this one line 1, and I'll call this one line 2. We can see that line 1 has a positive gradient. How would you find the equation of line 1? Can you see the y-intercept on line 1? What's the y-intercept? Yeah, the y-intercept for line 1, which is b, you know how we've got y equals mx plus b? The y-intercept is 4. And you should be able to work out the gradient of line 1 just using rise over run. So when you've got a nice graph and it's on a grid like this, you can actually see the gradient using any 2 points on line 1. I'm just going to choose these 2 points here. So to go from there to there, how much do I rise and how much do I run? So the rise over the run is 2 over 1. So for line 1, the gradient, which is rise over run, is 2 over 1, which is 2. So therefore the equation of line 1 is y equals 2x plus 4. So that's revision. Now the equation of line 2 has a negative gradient, and we can see already the y-intercept on line 2. Line 2 has a y-intercept of what? Negative 1. So the y-intercept, which is b, is negative 1 for line 2. And we can do a rise over run. I'm going to just do it down here, otherwise it'll get too messy up there. Picking 2 nice points on the grid. Rise 3, run where? Back or up 1? Back or forward? Back 1. So this one, the line 1 was rise 2, run 1. Line 2 is rise 3. Gradient is rise over run, which is rise 3, run backwards 1, so the gradient's negative 3. So the equation of line 2 is y equals negative 3x, and the y-intercept is minus 1. Now, in exercise 207, we were doing equations of lines, but you couldn't see the y-intercepts properly, and you actually didn't even have graphs, and we were doing it a different way. So 2 over 1 is 2, so the gradient's 2, sorry. I've got it right there, sorry. Okay, so they're the equations of both lines. That's just a bit of revision. Do you remember how we solved simultaneously? We should probably review that here as well. I'm going to do a quick review of solving simultaneously while we're here. If you've got the graph and you can see it quite clearly, you can see the point of intersection. Can you read it? What's the point of intersection? Negative 1, 2. So the point of intersection is the point negative 1, 2. But what does that mean? It means that x is negative 1, y is 2, is the solution to the simultaneous equations. I'm going to solve these simultaneously just for some revision because we did it last term, or last year actually. So let's have a look how to solve. Or I could solve y equals 2x plus 4 and y equals negative 3x minus 1 simultaneously. Do you remember how to do this? Just for some revision. I'll call that equation 1, I'll call this equation 2. This is the best type to solve. Y equals that and y equals that. so you can put the two of them equal to each other. This is the easiest type. Substitute equation 2 into 1 or 1 into 2, it doesn't matter. But this is the best type of simultaneous equation to solve. If y equals that and y equals that, then don't the two equal each other? Yeah. So this is the easiest type to solve. So we've got, so therefore 2x plus 4 equals negative 3x minus 1. Now it doesn't matter if I write sub 2 into 1 or sub 1 into 2 for this type. So now what do I do? 2x what? Plus 3x equals negative 1 minus 4. And so we've got 5x is negative 5. And I'll keep going. And so how do you work out x? Don't you divide by 5? X is negative 1. Do you remember these? And then we substitute x is negative 1 into either equation 1 or 2. I'm going to put it into equation 1 to get the y value. So y equals 2, substitute in the x value, which is negative 1. That means 2 times negative 1 when I put brackets. Plus 4. You okay with that? 2x, 2 times x I can write as 2 bracket negative 1. It's the same thing as times. So it's negative 2 plus 4, which is 2. So we already saw from the graph that the point of intersection was negative, x is negative 1, y is 2, and we got the same. X is negative 1, y is 2. So solving simultaneously or reading it off the graph, you would only read it off the graph when the graph is as clear as that one. And that is showing solving simultaneously, just the methods from last year that we looked at gives you the same result. Exercise 209 at Copycat Express, the charge for photocopying is 13 cents per sheet. Notice it says 0.13, so they're giving you the cost in dollars, okay? Class is investigating the purchase of his own photocopier for $1,200, which brings the cost down to 5 cents per sheet. So we're looking at two options here. Class can either go to Copycat Express and get charged 13 cents for every copy, so 0.13 times x, do you get that? Or if he buys his own photocopier that costs him $1,200, he's then going to pay 5 cents a sheet, so 0.05 times x, which is the number of sheets that it'll photocopy. The $1,200 is the upfront cost. Do you get that? So if he wants to, class wants to use his own photocopier, it's $1,200 to buy it plus 5 cents per sheet. So x is the number of sheets that he will photocopy, the number of copies that he makes. So where C is the cost in dollars and x represents the number of copies made. Now, what they've done is they've graphed both these areas. Now, there is a point of intersection right there. Now, there are two, so we've got a straight line there and a straight line there. And we've got a region here and we've got a region here. Now, whose graph, 0.13x, doesn't have a plus anything on it. The 1200 plus 1200, this is this graph. This graph here that I'm pointing to now is the 0.05x plus 1200. It's got a smaller gradient, number one, and it starts at 1200 on the y-axis. And the other one starts from 0, the other graph, 0.13x is there. Now, obviously the cost of photocopying is more expensive using his own photocopier up until a certain point, up until here. And then that line goes underneath the other line. So once class has made somewhere between 14,000 and 16,000 copies, his own photocopier will become cheaper for him, okay, in the long run. Now, he's obviously got a business. You're not going to do that if you're at home, all right? So, and the difference here between Copycat Express and his costs will be the profit he makes, okay? But anything up until there, class is paying more money if he only does less than, say, about 15,000 copies. Yeah. He's really got to think, how long's the machine going to last me? How many years? Do you know what I mean? How many copies will I make per year? Now it says, use the graph to determine which option is cheaper for 5,000 copies. So here's 5,000 copies. Who is cheaper? Yep, Copycat Express. Now you could, sorry, it's a C. So you could work out, I don't know if you can read it very well, but if you wanted to work out, so it says in part B anyway, use the formulas to find the cost of making 5,000 copies for each option. So for part B, so the Copycat Express, the cost is 0.13x, which is 0.13 times 5,000, which is, I probably should have done it up there. And then his own photocopier is 0.05x plus 12,000, plus 1,200, sorry, which is 0.05 times 5,000 plus 1,200. So has anyone worked those out yet? All right. So for Copycat, 500 copies, it's $650, and for his own photocopier, it's $1,450. Let's just have a quick look. 5,000, yeah, that looks good. And for the other one, that looks good. It's sort of, oh, you can't see what I'm doing. So just checking that the graph matches. 5,000, about 600, we got 650, that looks good. 5,000 for the other one is up here. We got about 5,000, sorry, we got 1,450, that looks good. Just making sure it looks right. Do you know what I mean? Okay, now, the part C says, why is the own photocopier option more expensive for small values? Because he must buy the photocopier for $1,200. It's his startup costs. Because he's got startup costs when he buys his own photocopier. What is the value of X at the break-even point? Now, look, that is a bit hard to see. It does look like 15,000. Look, but to make sure, we should solve simultaneously. So we're thinking from the graph, it looks like 15,000. But what not dollars, 15,000 copies. But what I'm going to do up here, we're going to solve simultaneously. So I'm going to move up and I'm going to solve simultaneously in this space here. I've got a bit of room. You ready? So, what are the two formulas? C equals 0.13x, formula 1. C equals 0.05x plus 1,200 is the second formula. To solve simultaneously, you sub 1 into 2 or 2 into 1. It doesn't matter which way, because they're equal to each other. And we go 0.13x equals 0.05x plus 1,200. So if you are not sure if you can read it correctly, you can solve simultaneously. That will give you the point of intersection. What do I do now? 0.13x minus 0.05x equals 1,200. 13 minus 5, 8. 0.08x is 1,200. So x is 1,200 over 0.08, which is, sorry? So it is 15,000 that you can read on the graph. And that just confirms it, but this is really good practice for solving simultaneously. Because sometimes it won't be a nice value that you can see. Question. But once you know that x is 15,000, I could ask you for the cost at this time. What? So I could... It is 15,000 copies for the break-even point. So what you could do, if you sub that into equation 1, you get that the cost at that break-even point, do you know what I mean, is 0.13 times 1,500. You can actually work out the cost. You know how this is a point of intersection? It's got an X and a Y value? Yeah. So in other words, the question is, it did say just how many copies, what's the value of X, it's 1,500, but in other words, he's got to do $1,950 worth of photocopying to get to that break-even point. Now, and the question is, part E, so the answer is X is 15,000, but I just went a little bit further and just gave you the Y value at that point as well. Because remember, when you solve simultaneously, you want an X and a Y value. You didn't need it, but I just put it there as well. Now, I could have put that 1500 into equation 1 or 2 and you should get the same answer. Sorry?
Is 1500 then the x above this 15,000?
Oh, sorry, 15,000, guys. Can you fix that? I gave you the wrong, I just got an extra 0, I think. 15,000, sorry. X is 15,000. Is it 19,000? Yeah. No, it's 1,950. It's only 0.1 times that. I just wrote the wrong number there, but it's correct. 1,950. Having a look here, 15,000 looks good, 1,950. Okay? Just showing how you can solve it. It's 1,950. I just missed out a 0. Now, part E, what happens when X exceeds this break-even point? What happens? What becomes, yeah, but what becomes cheaper? For him to use his own copier or his own, yeah. So once he has exceeded 1,500 copies, his own photocopier becomes cheaper to use, becomes cheaper to use. Okay, and you are now in the profit zone. Now in the profit zone, using your using your own photocopier. Do you know what I mean? It's not like, yeah. So look, you'll use that profit zone more for it costs this much to hire this hall, and so many people are attending. How many people have to attend the function before you break even and make a profit? Do you know what I mean? Or how many items do you have to sell to make a profit? We would just say that once he's exceeded 15,000 copies, his own photocopier becomes cheaper to use, okay, than Copycat. The cost of purchasing N new DVDs from a store is cost equals 16N plus 576, while the monthly income earned from renting out those new DVDs is I, which is income, equals 48 times N, where C and I are both in dollars. Now, it says to graph both functions. I did them for you. I just got them from the answers. All right, so that's done. Graph both functions, already done. Do you know how you would graph them anyway? I don't think they'd make you do it. You would just choose some values of N, like 10, and work out the C and plot, etc. Same with the other one.
Why do they do that?
So both functions have been graphed. Notice the 48N1 has no y-intercept. It starts at 0. And the y-intercept for the 16N plus 576 is at 576. Now, the first question is, what would happen if the store bought fewer DVDs than the break-even value of N? So, you know how in the last question we saw the profit. This is the money you take in, and these are your costs. In this first section here, this is not profit. This is a loss. You're running at a loss in this section. In this section up here where your income is greater than your costs to produce or cost to manufacture or cost to run the business, income is greater than cost. Now we're in the profit zone. So when your income is greater than your costs, you make a profit. You make a profit. And when your income is less than what it costs you to make something, you make a loss. So on our graph, this is my profit zone in here, and this is where I make a loss in there. So a loss and a profit there. So the question is, for B, what would happen if the store bought fewer DVDs than the break-even value of N? What would happen? They would make a loss. Question C, calculate the monthly costs of purchasing 35 DVDs and the income earned from these. So you will use the formula. So the cost, so if N is 35 DVDs, the cost is 16N plus 576. I need someone to give me the answer. 16 times 35 plus 576. And you can work out the income as well. The formula for that is 48N. So it's 48 times 35. Cost of purchasing 35 DVDs is 1,136, and the income earned from these is 1,680. If we look at our graph, 35 DVDs, bit hard to read it off to get an exact answer, but you can see you're definitely making a profit there, and you are, because there's more income than cost. All right, this is in the profit zone here. Okay, so according to the formula, what monthly income is earned from each new DVD? According to the formula, what monthly income is earned from each DVD? Well, I don't know. Let's look at the formulas. So D, the income is 48N. I just want to note here for question C, that is in the profit zone there. And if you actually wanted to work out the profit, it's not asking you to, but you could work out the profit, and it's 1,680 minus 1,136 for 35 DVDs. Okay? So it's not asking you to do that, but you could work out the profit there if you had to. Do you get it? Profit's the difference between those two. I'm not sure what that equals. Now, Part D says, according to the formula, what monthly income is earned from each new DVD. See, if one DVD is sold, you earn $48. If 2 DVDs, $96. So the income from each DVD is just $48, according to the formula.
Yeah, it's 48.
Yep. And the last question says, what is the vertical intercept of the cost graph? So what is the vertical intercept of the cost graph, and what does it represent? Now, here's the cost graph. The cost graph formula is C equals 16N plus 576. What does it represent? Just think of what the constant represented in our last example, the $1,200. What do you think the 576 represents? So the y-intercept, or the vertical intercept, or the y-intercept, that's the vertical, is 576. And that's a constant. What does it represent? You can just call it your startup costs or your monthly costs, your ongoing. So 576 represents, because it says the monthly cost is, I would put your monthly costs. Maybe to run, it's just your monthly costs for the business or something. Just your fixed, just put your fixed monthly costs, okay? So you've got to pay that 576 whether you sell one DVD or none to run the business, okay? So 576 represents your fixed monthly costs. Okay.
That's the vertical intercept.
Yep. And you know it's monthly because you look at the information given in the question and it says the monthly cost of purchasing N new DVDs for a video store is that. So that's your monthly cost. Jenny is comparing 2 internet cafes. QuickBite has a monthly membership fee of $8 and charges 60 cents per hour of internet use. And Game Hunters charges $1 per hour of internet use, but has no monthly fees. Now let's see how they get these formulas. 60 cents obviously has to be changed to hours, which is 0.60. So QuickBite is $8 plus 0.6 for every hour. So T must equal the number of hours, and it does. And it says Game Hunters, that the formula is C equals T because it's C equals 1 times T. Because Game Hunters charges $1 per hour, but no monthly membership fee. So this plus 8 is a fixed cost, the plus 8. And this one is 0.60 times T plus the $8. Okay, that's how they get those. Now, sometimes they might ask you, I think in one of the HSC questions we're going to do, they do ask you to write your own formula. Okay? Now, it does ask you to graph them, but I already did them. Now, if you were to graph, don't go up and go T is 1, T is 2. Go like 10, 20, 30. You'll get better values. Look, what might happen in the HSC is that one of them might be graphed and you have to graph the other. But you know how to substitute values. You might go, when T is 10, 0.6 times 10 is 6 plus 8 is 14. So if I look here, when T is 10, I get 14 for the cost, etc. And for the other one, C equals T, whatever the time is, the cost equals the same. Looking here, 5, 5, 10, 10, 15, 15, etc. Now, the question, they're already graphed. We have to find the break-even point. So what's the break-even point from your graph?
20.
Yes, so 20 hours. So the break-even point is T equals 20 hours and the cost will be $20. We okay with that? Time on the bottom. Make sure you put the units in. Don't forget to put the units. Cost is $20. Part B. If Jenny uses the internet cafe for $24 a month, for 24 hours a month, sorry, which cafe is better for her and why? So, if the time is hours per month, which one's going to be better? You can have a quick look and you should be able to see it. 24 hours. But if you want, sorry, I'm at the wrong spot. 24 hours. Which one's better? Quick time's better. Quick bite is better by a couple of dollars. So I'm just going to work them both out. Quick bite, we can see from the graph, is cheaper. From the graph. And if you want to work it out, quick bite, and it asks us anyway. So for part C, it asks us anyway. Which cafe is better? Why? Why is it better? Why is it better? Because it has a lower cost. As it has a lower cost. And then you can use the formula for each. So using T is 24 hours for part C, you can look at quick bite is C equals 0.6 T plus 8. 0.6 times 24 plus 8. And you can use Game Hunters as well and work out how much Game Hunters costs as well for 24 hours. C equals T, in other words, C equals 24. Now we know that quick bite is going to be slightly better. So 0.6 times 24 plus 8. The reason the answers are really close is that it's just above the break-even point. So sorry, that blue line shouldn't be there, but $24, the break-even point's at 20. So at 20 hours. So 24 hours is not much more because it's only 60 cents extra an hour. The difference will be $2.40 because it's 60 cents an hour extra times 4 is $2.40. So the difference, sorry, actually, it's not $2.40. It's the difference between those two. So the difference is 24 minus $22.40, which is $1.60, sorry. So the difference is, so we've worked out the cost for each, and the difference is $1.60. In other words, quick bite is cheaper by $1.60. Okay? And now the last question, D. Compare the advantages of each cafe taking the break-even point into consideration. So, what would you say? When is quick bites good? What's an advantage of quick bites? If you're going to use...
When you use more than 20 hours of internet a week, a month.
So when's, sorry, quick bite is, no, Game Hunters is cheaper if you're less than 20 hours a month, isn't it?
But if you use more than 20 hours, which you
Yeah.
really do.
So Game Hunters is cheaper if you use less than 20 hours a month,
Pretty much.
which is the break even. And which one? Quick Bite is cheaper if you use more than 20 hours a month. Okay? And if you use around 20 hours a month, I suppose you could go with either, but you know, yeah. And another advantage is there's no fixed monthly cost for Game Hunters in case you're not there or something like that. Also, there's no fixed monthly cost for Game Hunters as well. Okay?